Great. So good morning, everyone. It's an honor to be here today among innovators, builders, and decision makers shaping the future of the industry in Saudi Arabia. So today I'm going to talk about the importance of combining data, connectivity, and people so that we can build the smart factories of tomorrow. So as we know of today, that the mechanical beginnings of factories started, and now we are shifting to the cyber-physical system factories. This is what we call it. So we are facing another turning point, one that is defined by raw power, but intelligence and connected systems. So factories are no longer just a place where things are made. They are becoming sensing, thinking, and adapt to future scales. So if we look through the evolution of the industrial revolution from the first to second and third and fourth, we are now here of cyber-physical system. And the complexity is evolving at the same time. What are smart factory promises? They promise an improvement in productivity, optimizing asset performance with advanced analytics, empower data-driven decision-making, and optimize operational costs. Those are what the global leaders have achieved, about 5 to 10x return on investment, 30 to 50% reduce in downtime, and 30% increase in labor productivity, to 20 to 25% increase in production. So those are real value that are applied for global leaders that have implemented those new technologies and are leading in Industry 4.0. And here is the problem that we are having right now. Despite all the promises of Industry 4.0 technologies, productivity gains have stagnated. So here we can see during the third industrial revolution, over time we had an increase of production, and during the era of the fourth industrial revolution, we have a productivity that stagnated. Why, you would say? Because technology without strategy doesn't create value. So this illustrates a failure to extract value from this digital transformation. It's not the lack of tools that we're having, but of effective execution. So does it mean when we increase the digital investment that we'll have optimally an increase in productivity? So the lack of system integration and siloed data will create those types of results. The root issue is not the adoption, but it's how the strategy that we are using to get to this digitalization aspect. So here, I want to talk about the foundation and how to build to avoid those gaps. So the factories that are leading right now are those who build strengths in those three areas, which are data, which is the foundation of the intelligence, that need to be collected, contextualized, and provide insight so that we can have action in it. Connectivity as well, which is the architecture and infrastructures of all of those data and software and different tools, how they are connected together to create this value. And of course, the most important is the people. So, because even with the perfect data and flawless connectivity, nothing will change unless the people at every level, so we're talking about every level, whether they are engineers, technicians, executive, and operators, they need to be equipped, informed, and empowered to act. So we will go straight to and the most important part is not each one of them individually. It's the combination of all of them. So it's by combining those three aspects that we will reach our goals. Now, to get into the data is no longer a byproduct of production. It's the engine of the performance of the factory. So from maintenance to sustainability goals, everything uses data. But data should be well thought. We shouldn't just take any types of data and analyze them. we need to have a good structure and a good strategy on how we're going to acquire this data, develop it, and gain insights from it. So here's the main point of how any data acquisition works. We can have sensors. It can be also a historian based on our softwares, and we'll acquire this data, integrate it to derive the information from it, and we will gain some insight for decision making so that we can have an action. So this is basically it. But we can see that 60% of analytics initiatives are failing due to the poor data quality. And we'll see why. So first, there are different types of data that should be taken in any types of factory. So this is to make factory more intelligent. We talk about operational data type. This is what that's used for real-time processes, monitoring, and automation. Quality types of data for quality control, especially in food and beverage. Asset health, this is predictive maintenance and utilities that is used. Workforce, which is to monitor the labor productivity and safety analytics, and to optimize training, which will be an important part of the digitalization journey, and we'll talk about it later. And of course, sustainability. That is now one of the first aspects in Saudi to measure for ECG reporting and regulatory compliance. But what makes this data usable? So why are we having issues to gain insights from this data? Because first we need to know that the data, when we use sensors, is it to be accurate. So the sensor needs to be calibrated. And this is something that should be done every so and then, every 1 year, 2 years, depending on the sensors. Contextualize is very important in Industry 4.0 because we are having a very complex architecture. I will talk about it later. Accessible, so this is where we talk about connectivity, how all the softwares are connected together. And real time, of course, it's to gain minimal latency, especially when we work in processes that require a lot of precision. And structured. Now, we extracted the data. What do we do with it? So normally factories are here now, descriptive and diagnostic. So what they do is something occurs, they have the data, they're checking what happened and why it happened. Now, smart factories, what they're doing with advanced analytics is in those two cases. So predictive and prescriptive. So they will gain knowledge of what will happen and what action to take. So this is the future. So we're going to start with the most important aspect of this analytics, which is predictive capabilities. So when we combine historical data from our softwares with other assets data that we extract with sensors, and also process data, we extract them, analyze them, derive some information and insights. How do we derive those informations? So those are advanced analytics. Those are mainly used for predictive maintenance algorithm. So for sure, data should be processed, cleaned, and then we go to feature extraction. So here is where we getting to advanced analytics, where we have clustering classification, so that we can recognize different patterns and we can expect what will happen. And we'll get to the AI-driven modeling and decision support, so we can forecast and predict and understand what will happen. Now, so this is an example of a software of predictive maintenance. We can see here we are measuring a sort of data that is continuous. We have in the green light here, which is the lower threshold, and in orange above, which is the higher threshold. So currently, those are the data that we are reading now, and this is the prediction that we are having. So the software will predict it, and we'll have the level of confidence, and we can know that there is an issue that is happening. Now, okay, we know that an issue is happening, but how we will know what to fix? So this is where we were talking about contextualize those data. So here's an example. We have a pump. The pump is built of two mechanical parts, a bearing and a cooling system. And each one of them has a subcategory. And the same goes on and on. So this is what we call diagnostic and signature. So we are doing a root cause analysis and gaining insights on exactly what is happening to our asset so we can know what to fix and where the issues come from. So that we don't change the whole system, but we'll fix specifically what is needed to be fixed. Here's another example. We have here a rotary asset used for electricity. It has multiple components, and each component had its own subcomponents, and each one of them can fail differently. So here's when we talk about how we should contextualize our data. So if we don't have data that is contextualized, we will never know what is happening and what is the issue. So those are a very important strategy to understand and to act upon it. Now, the end goal is, of course, we have all of those softwares, all of this data that we're analyzing, and on every level, what we need is a centralized dashboard that will have everything at every level. Engineers will understand the dashboard. Executive will understand another one. But all of them need to be connected. The issue that we are having now is that we have what we call data silo, which is the maintenance people will have their dashboard and their data that is disconnected from the other softwares. The executive will have a PowerPoint at the end of the week, and other engineers will have their own table. So nothing is connected. And this is the issue that is happening right now. So we need to reach this goal. How do we do it? With connectivity. So as we all know that factories today are built over time, and they are not built from scratch. That means that it uses different technologies, different suppliers for different systems or machine, different generation of systems as well. And so we have a sort of patchwork of components that will create this complexity. So we can see here, we can have legacy machine, modern sensor, different types of gateways, different factory softwares, different also cloud platform. And so it creates this fragmented architecture. And we should put it together and connect everything together to unify it. And this requires a very extensive strategy to be able to do that. So here's the goal. We will have, let's say, the process IoT, so the sensors of the process, what we're other condition monitoring for predictive maintenance, so extracting data from our machines, and in a way, this is simplified, connect everything together so that machines can talk to machines, system can talk to sensors, sensors can talk to systems, sensor can talk directly to some management software. So we need to have this connectivity. And this is what we see. So before, this was the architecture that we were having in factory. So it was a linear connection. So we had the field devices, sensors or actuators that will talk to the automation layer, and then to the supervisory layer, then to the manufacturing execution, and then to the ERP or management system, to the cloud. And today, we don't have this linear model anymore. In cyber-physical system, this is what we have. So it's like a web architecture, very complex, where we'll have our smart device that can directly talk to the cloud, different machine talking between them, system and machine. So this is what is required now, this complexity, web form. Yeah. And now also there is this new technology that is coming up that is called connected worker. So what is connected worker is, we know that people are now, it's having people and workers as an active node. So I added it here. So as an active node, that they will have a gateway on them. They will wear different kind of devices that will help them doing their work, and also directly connect them to this whole connectivity structure. So we can see here, we have different devices. It can be AR tools, some safety watches so that we can monitor the health. So this is mainly important for mining industry and the oil and gas industry. Those are some of the case studies. So smart worker profile and tool assignment. So mainly it's, I put the device, I'm entering a new location, I will be required to wear specific tools to get there, especially in oil and gas. So I will be requested by the system, okay, you're entering this place, you should do this, do it like that. And another important thing, when we talk about training the operators, augmented reality helps a lot. So there are a new solution where we have augmented reality glasses and where we can train from outside any operator in the field. And now we saw that people can be connected. Let's talk about the people and how they are connected to this whole system. So as we said, it's the most important piece because even with all this data and flawless connectivity, nothing will change unless we train the people. So we can see here that 72% of digital failures are due to the lack of workforce readiness. They are not ready to use those tools. So every transformation should begin with it. So what does the future ready workforce look like? Those are the skills. Data literacy, they are able to read trends, KPIs, they are digitally fluent, they know how to use industrial Internet of Things tools, augmented reality tools, and other wearables. They're good at analyzing charts for root cause analysis, optimization, like the example of predictive maintenance software that we showed earlier, they will need to be aware of how to use the software and how to read it. And also AI collaboration. So it's not only about how to use a certain type of software or how to use AI, it's mainly also to have trust in it. So am I trusting it or not? So to enable the future of workforce, we have this circle. So we need to assess the skills of our people, try to partner with academia to also build the future workers, and deliver immersive training and continue this loop. It's as we said, technology is evolving every day. We should always assess the skills of our people and see if they're ready for the next technology that is coming up. So this is the smart factories. We have smart assets, we can monitor them, connected workers where people are augmented, and enabled connectivity. Everything is connected together. And when we talk about the Saudi Arabia market, it's not just catching up. Vision 2030 here is not about following any types of buzzwords or reacting to a global trend. It's about building internal capabilities that will position Saudi industry as a global benchmark in the world. With national programs supporting AI, advanced manufacturing, and workforce development, Saudi Arabia is actively shaping the future of smart manufacturing and not just participating in it. So this is the truth. One size fits all doesn't work anymore. Your system, your processes, and people are unique. So your solution must be as well unique. So that's why Smart Factory must not buy systems, but build them. Let's not just catch up to the future and trends, and let's lead it. Thank you.